Greetings and welcome once again to Edu-ca-te. If you had watched our previous video on an atom and on valence electrons, you're at the right place. But then if you haven't watched that, please consider that watching first so that you get more clarification as we go through the video. Today we're going to be talking about Lewis dot diagrams. So Lewis dot diagrams are just these diagrams of representing an atom symbol alongside its valence electrons. It's as simple as it can be. So for example, you have got here an atom of lithium. You can see that this is an atom of lithium. How can you identify? It's because of its number of electrons, the number of protons, and the number of neutrons. So these are the basic things that are used to identify exactly which atom or which atom exactly is this. So here in this case we've got lithium and we want to draw its Lewis dot diagram or its Lewis dot structure. So how do we draw this? Do you even have an idea what a Lewis dot structure is? So a Lewis dot structure is basically the structure that represents this symbol. This is the symbol of an element. You can relate that from going to the periodic table. The periodic table contains elements, so the elements contains the symbol. So we identify the elements by looking at its symbol. So the symbol of lithium in this case it is Li. So in this case Li is going to be the symbol we are going to be using to draw out our diagram. So here you've got lithium. You can see lithium. Now we want to draw its Lewis dot structure. Remember, the Lewis dot structure deals about representation of valence electrons. So here, how do we represent that? We just put this valence electron here. It's simple. Now you're done with the lithium's Lewis dot structure by just representing. You can see this red is representing the valent electron of lithium. Remember that according to our previous video that talks about valence electrons are these electrons that are on the outermost shell of that atom. By outermost, it just means it is the furthest from the nucleus comparing to the other. So here in this case, lithium has got this one electron in that in this. So this is how you represent a Lewis dot diagram of lithium, because it's got only one valent electron. Let's take another example so that this becomes very easy for you. So let's go back to the periodic table and take for example the atom of nitrogen. So here we've got nitrogen here. So let's try to represent this in form of the Lewis dot structure or the Lewis dot diagram. So how do we do this? We just have to first draw the atomic structure of the nitrogen. So how do we draw the atomic structure? The atomic structure is drawn on the basis of the electrons, the protons, and the neutrons. That's simple. You just have to draw your nucleus here, and then you check out exactly how many protons have you got, how many neutrons, and how many electrons. So in this case, we've got nitrogen. Nitrogen have got an atomic number of 7, which is the number of protons and the number of electrons, and also the number of neutrons, because if we subtract 14, the mass of nitrogen, and 7, which is the atomic number, you will get still 7. So here we've got our protons: 2, 3, 4, 5, 6, 7. So these are the protons, the positive charges, and neutrons are also 7. 1, 2, 3, 4, 5, 6, and 7. Now you have represented all the protons and the neutrons in the nucleus. Now we have to focus on drawing the orbitals. So the orbitals, you have to draw orbital number 1, which will contain 2. So orbital number 1 will contain only 2 out of all those 7 electrons. So if we're going to do a data analysis, we have 7 electrons. So this symbol E with a negative, it means we are representing electrons which are negatively charged. And then the symbol P with a positive, it represents the protons which are positively charged. So we've got 7 protons and 7 neutrons which are neutral. So in this case, how are we going to represent our electrons? At first, don't forget that the first orbital can contain only a maximum of 2 electrons. Therefore, do not put more than that. So here you have 2 represent your 2 electrons. Remember, we've got 7 electrons in total, so do not make a mistake and draw 7 electrons on the second orbital. Reason being, we've already covered the 2 electrons in the first orbital. So the next thing you do, you just have to draw your second orbital. This orbital must cover all the 5 remaining electrons. Remember, we have 7 electrons initially, therefore we have to represent these 5 remaining since we've covered the 2 already. Therefore, here you just have to create spaces for 5 electrons. 3, 4, 5. Here it's 1, 2, 3, 4, 5. You can see now we've represented all the electrons that are contained by what? That are contained by the atom of nitrogen. So here we can now determine the number of valence electrons. Remember that the valence electrons are these electrons that are found at the outermost shell. So how do you determine the number of valence electrons in nitrogen? So in nitrogen, you just look at the outermost shell. Remember, the outermost shell is the shell that is the most furthest from what? From the nucleus. You can see the distance here can be something about 10 meters and the distance here can be only 2 meters. So this means that this one is the most furthest from the nucleus in this case. So this one is the outermost. Therefore, you have to count exactly how many electrons do we found in the outermost shell. So let's try to identify that, and then you can find 2 here, 3, 4, and 5. So the number of valence electrons of a nitrogen atom is 5. So valence electrons is equals to 5. So this is your number of the valence electrons. So the next thing you have to do is to now draw the Lewis dot structure of nitrogen. So remember, the Lewis dot structure has to do with valence electrons and the symbol of that element. So you have to draw you have to first write down your symbol, which is N, which represents nitrogen according to the periodic table. So now you have to represent the 5 valence electrons you have calculated over there in this form of Lewis dot structures. You just have to use dots or x's. You can use x's or dots, it's still the very same thing. So how do you represent this? This 5, note that you have to represent it in pairs. We have pairs to represent this thing. So first we can represent the first one. 1, 2, 3, 4, and 5. Most of you can even wonder as to exactly why did I not pair these 2 things up, because I had said that we need to represent these things in pairs. The reason I did not pair these things in pairs is because this atom needs is balance. By balance, I just means this symbol must be surrounded by these electrons all around, except for hydrogen and helium, which have got only as a small number of valence electrons. So now if we are going to represent these electrons, they have got to equalize here. If we're going to take this pair and be like here, let me just, yes, and then 1, 2, 3, 4, and 5. This side will be left unbalanced, so it will result in something like this if we're kind of being general. So it will result in something like this. This is balanced, and then this is not really balanced. You can see now it's no longer balancing itself. So in total, these valence electrons have to balance and to spread throughout, or to spread all around this symbol of nitrogen. Therefore, we have to represent these atoms here, these valence electrons separately like this, so that this will be a balanced atom of nitrogen. Thank you for watching. Stay tuned for the next video.